All right, we're going to take a look at rational power and root functions. Rational function, the function f of the form f of x equal to p of x over q of x, where p of x and q of x are polynomial, where q of x cannot be equal to 0, is rational function. You cannot have qx equal to 0, that becomes undefined. So example of rational function basically would be a number or polynomial over polynomial. So in this case, f of x equal to 1 over x. The number at the top of the fraction is a constant, and the bottom of the fraction we have a polynomial x. Another example of rational function would be f of x equal to x plus 1 over this other polynomial. The simplest rational function, you may want to write this on your summary sheet, f of x equal to 1 over x. So f of x equal to 1 over x, if I use my calculator, you can see the basic graph of this function. But let's take a look at some of the characteristics of this rational function here. Now, if you look at the numbers that our calculator shows, as x approaches 0 from the left, y1 decreases within the bound approaching minus infinity. As x approaches 0 from the right, y1 increases without bound approaching plus infinity. Also, as x approaches infinity, y1 approaches 0 through positive values. As x approaches negative infinity, y1 approaches 0 through negative values. This all would be very clear as you take a look at the graph itself. So if you look at this here, this would be a basic graph of y is equal to 1 over x, or f of x equal to 1 over x. The domain of the function, as you can see, would be all the number from negative infinity to 0, and also from 0 to positive infinity. As you can see, there is no graph at x is equal to 0. That would be the domain. The range would be also from negative infinity to 0, from 0 to infinity. We have these lines here, we call it asymptote. This is a vertical asymptote, and there's a horizontal asymptote. The asymptotes are the line that your graph gets closer and closer to that. It's kind of like a magnet. It pulls the graph toward that line, but it never reaches that line. You get really, really close to that. F of x equal to 1 over x, decreasing on the open interval. All these should be pretty obvious. It's decreasing from negative infinity to 0, and from 0 to positive infinity. It is discontinuous at x equal to 0. You can see that there's no graph at x equal to 0. The y-axis is a vertical asymptote, and x-axis is your horizontal asymptote. These are the lines that your graph gets really close to that. It is an odd function, and its graph is symmetric with respect to origin. Let's take a look at this other graph. Graph y is equal to minus 2 over x. I'm going to use the fact that I know how to graph y is equal to 1 over x to graph y is equal to minus 2 over x. To do that, I need to rewrite y is equal to minus 2 over x as 2 times 1 over minus x, and I'm going to pull the negative out. So y is equal to minus 2 over x is equal to y is equal to 1 over x times minus 2. We already know how to graph y is equal to 1 over x. So the graph of y is equal to 1 over x is, in this case, is stretched vertically by the factor of 2, because we have this 2 here, and reflect across the y-axis because it's minus, or x-axis. So if you take a look at the graph of the function, you see that would be identical to the graph of y is equal to 1 over x. However, it's going to see those stretch with the factor of 2 and also reflect across the axis. And the domain and range would be from negative infinity to 0 and 0 to positive infinity. Let's take a look at this other graph. Y is equal to 2 over x plus 1. I'm going to rewrite this as 2 times 1 over x plus 1, and use the fact that I know how to graph y is equal to 1 over x to graph this one. As you can see, the graph of y is equal to 1 over x compared to 2 times 1 over x plus 1 is shifted left 1 unit, because you have x plus 1. This really is x minus minus 1. So your shifting is minus 1 So it means it's shifted left 1 unit and stretched vertically by a factor of 2 because of this number 2 here. So if you take a look at the graph of the function, as you can see, is the same as graph of y is equal to 1 over x, with the exception of the shifting and stretching here. The domain would be from negative infinity to minus 1 and minus 1 to infinity now because it's shifted. The range would be from negative infinity to 0, 0 to infinity. And the vertical asymptote, as you can see, is changed. The vertical asymptote would be the x is equal to minus 1, and the horizontal asymptote still would be the x-axis, y is equal to 0. If you use a graphing calculator, you can see the shape of your graph as we use the shifting method. Use division and translation to graph y is equal to x plus 2 over x plus 1. First, we rewrite this expression by dividing x plus 1 into x plus 2. So I really know how to use a long division to divide. So if I divide x plus 1 to x plus 2, as you can see, the quotient would be equal to 1, and the remainder would be equal to 1. So this is 1 plus 1 over x plus 1, remainder over the divisor. So this would be equal to 1 plus 1 over x plus 1. So we can graph this by shifting the graph of y is equal to 1 over x to left 1 unit, y left, because this is x minus minus 1. We're shifting 1 unit to the left, and then here would shift the graph 1 unit up. As you can see, the same graph of y is equal to 1 over x is shifted. So now my asymptotes are shown here. The domain would be from negative infinity to negative 1, negative 1 to infinity, and so as the range. So that would be the graph of the function. Reciprocal of square function. This is another graph that you want to include in your summary sheet. Basic graph of y is equal to 1 over x squared. Increases on the open interval negative infinity to 0 and decreases on open interval 0 to infinity. It is discontinued at 0, x equal to 0. There's no function going there. The y-axis is a vertical asymptote, and the x-axis is a horizontal asymptote. It is an even function, and its graph is symmetry with respect to the y-axis. Let's take a look at graphing y is equal to 1 over x minus 1 squared. This is the same as graph of y is equal to 1 over x squared, except is shifted 1 unit because you have x minus 1 squared. So that's the same graph, except is shifted to the right because you have x minus 1. So your shifting factor is 1 here to the right. Same graph shifted to the right, so move the asymptote here to x is equal to 1. So the vertical asymptote is x equal to 1. The horizontal asymptote still is equal to y is equal to 0. And you can see the domain would be from negative infinity to 1 and 1 to infinity. And the range is from 0 to infinity. As you can see, we can confirm this result using our calculator. Let's take a look at this other graph. Graph of y is equal to 1 over x plus 2 squared minus 1. So if I know how to graph y is equal to 1 over x squared, I can use the shifting method on this one as well. The graph of y is equal to 1 over x squared is shifted to the left 2 units because here we have x minus minus 2. So shifting to the left 2 units. And then this is minus 1. You're going to shift down 1 unit. So as you can see, the same graph shifted. And the asymptote now would be x equal to minus 2 and y is equal to minus 1. These are your vertical and horizontal asymptote. And the domain would be from negative infinity to negative 2, negative 2 to infinity, and the range would be negative 1 to infinity. A graph of y is equal to f of x is shown here. Now we have a graph. We want to answer each of the following questions. Identify any vertical asymptote. Do we have any vertical asymptote here? Remember, the vertical asymptote are the lines that your graph gets closer and closer to that. Looks like we have a couple of them here. You have one vertical asymptote right here at x is equal to negative 2, and there's another one that x is equal to 2. And we have a horizontal asymptote also here at y is equal to 2. So x equal to minus 2 and x equal to 2 would be my vertical asymptote as it's shown there. The horizontal asymptote would be y is equal to 2, that would be this line right here. That's y is equal to 2. That's my horizontal asymptote. My vertical asymptote is x is equal to 2, x equal to minus 2. We want to find if there's any x or y intercept. We want to see if your graph intercept x-axis or y-axis. The only place that the graph intercept x-axis is right at the origin here. So 0, 0 would be the only intercept for x and y axis here. It passes through the origin. So as f of x goes to infinity, in this case, x approaches 2. And as f of x approaches 2, as x goes to infinity. As x goes to infinity, f of x approaches 2.